Happy learning! Today we're going to talk about quadratic functions, parabolas. So what is a quadratic function? A quadratic function is, well, a function of the form y equals, right? It's a function, so it's y equals something. What is it? Ax squared plus bx plus c. Where a, b, and c are real numbers, so they're just some numbers. And a is not 0. All right, if a was 0, then it would be a linear function. It would not be a quadratic function. And the graph, so we're going to graph these functions. So the graph of a quadratic function is a parabola. That's the name of the shape of this graph. All right, so it's going to look something like this, or something like this. So we either have parabolas that are opening upwards or opening downwards. The bottom is called the vertex if it opens upwards. If it opens downwards, the top is called the vertex. All right, so the vertex is a point on the parabola. Another property of parabolas is that they're symmetric about the vertical line through the vertex. So this vertical line is known as the axis of symmetry. So it's like a mirror image on the left and the right. And then similarly here, we have an axis of symmetry. My drawing stinks, so it doesn't look symmetric, but this one's actually pretty good. So you can see the left-hand side is equal to the right-hand side. All right, how do we find the vertex? There's a very simple rule for finding the vertex. The vertex is the point the x component is negative b over 2a. And then the y component is what you get when you sub this in for x. So I'm going to write that as f of, so the function evaluated at negative b over 2a. All right, so our x component is negative b over 2a. And then you just plug it into the function to figure out what the y component is. The axis of symmetry is the line x equals negative b over 2a, right? X equals a number is a vertical line. So x equals negative b over 2a is the vertical line that goes through the vertex. OK, so let's take a look at an example. So let's find the vertex and sketch the graph. Of the function 2x squared minus 4x plus 4. All right, we don't really know many properties of sketching the graph. I will tell you one thing. The graph opens upwards if a is positive. So if our a value is positive, we have an upward facing graph. And if our a value is negative, it's a downward facing graph. So the number next to x squared tells us whether our parabola is opening upwards or if it's opening downwards. So here a is 2. So our parabola is going to be opening upwards. But let's find the vertex. So how do we find the vertex? Well, it's right there. Okay, the vertex is the point negative b over 2a, and then the function evaluated at that point. So for the vertex, x equals negative b over 2a, which in our case is negative negative 4. 4 over 2 times 2, 4. X equals 1 is the x component of our vertex. This is also our axis of symmetry. To get the y value, it's our function evaluated at 1. So that's 2 times 1 squared minus 4 times 1 plus 4, which is 2. Our vertex is the point 1, 2. All right, so let's now graph our parabola as best as we can. We have just the vertex at this point. We're going to learn by the end of this video some more details that we need. But we know the parabola is facing upwards, and it has a vertex 1, 2. So there's our vertex, and it goes in this shape. It should be symmetric about the vertical line, x equals 1. So that's a rough sketch of what this parabola looks like. So let's look at an application now. So suppose we have a profit function. Right? Suppose we have some business and we have a profit function given by p of x equals negative 0.1 x squared plus 300x minus 1200. What I want to, so for the profit function, this, let's find the number of units. That gives the maximum profit. And we're going to find the maximum profit. All right, so pause the video and think of how would you solve this? Welcome back. This function is a parabola facing downwards, right? Our a value is negative. We want to maximize our profit. We want to find the vertex of this parabola. All right, so x, the number of units, is going to be the x component of the vertex. The actual profit is going to be the y component of the vertex. So to get the x component, it's negative 300 over 2a. 2 times negative 0.1. All right, you could just type this into a calculator. That's 1,500 units. So our profit is maximized if we sell 1,500 units. But what would our profit be? Well, we need to figure out what our profit at 1,500 is. So we sub in x equals 1,500. And if we just type this into a calculator, that's 223,800. So our profit is maximized at 1,500 units, and the actual profit is $223,800. Okay, and so what we're going to talk about now is what information we need to accurately graph a parabola. The sketch that we gave in the last example, or 2 examples ago, was good and all, but we want it to be a little bit more accurate than that. So this is graphing parabolas. Okay, so we already stated this, but let's state it again. If a is greater than 0, we open upwards. If a is less than 0, the parabola opens downwards. That gives us a general sense of the shape of the parabola. Next, we need the vertex, which we've already talked about. So remember, for the vertex, x equals negative b over 2a. Y equals the function evaluated at this number, right? This negative b over 2a is just a number. Okay, so it's the function evaluated at that number. The axis of symmetry. The axis of symmetry is that vertical line that goes through the vertex. What else do we need? We need the intercepts. When does our parabola cross the x-axis? When does it cross the y-axis? All right, so we'll start with the x-intercepts. So the x-intercepts are when our parabola crosses the x-axis. Another way to say that, that's when our y value is 0. So 0 equals ax squared plus bx plus c. How do we solve this? This is a quadratic equation. So we could factor, or we could use the quadratic formula. Okay, so these 2 values, potentially 2 values, could be 0, 1, or 2 values, give us the x-intercepts. And then the last thing we need is the y-intercept. So how do we find the y-intercept? The y-intercept is when our parabola crosses the y-axis, which means it's when our x value is 0. So it's y equals a times 0 squared plus b times 0 plus c. This term goes to 0. This term goes to 0. C is our y-intercept. So our y-intercept is the point 0, c. If we have all of this information, we put it together, we're going to have a beautiful graph of a parabola. So let's take a look at an example. So our function is y equals negative x squared plus 4x. And we want to graph the function. All right, and we're going to use these points here. So first thing we need to check is our a value positive or negative? Our a value is -1. -1 is negative. So we're going to be opening downwards. So I'll just mark that there so we keep that in mind. Next, we need our vertex. X is negative b over 2a, -4 over -2. 2. Okay, y is -2 squared plus 4 times 2, which is 4. Our vertex is the point 2, 4. Axis of symmetry. This is easy once we have our vertex. It's this number, x equals 2. X-intercepts. We could use the quadratic formula. There's no shame in that. I'm going to factor here just because it's pretty easy to factor this, right? X squared minus x squared plus 4x equals 0. This factors into negative x times x minus 4 equals 0. So this gives us x equals 0 or x equals 4. So our x-intercepts are the points 0, 0, right? X is 0. Y is always 0 on our x-intercepts. And 4, 0. These are our two x-intercepts. And then finally, we need our y-intercept. And we get that by reading off C. There is no C, so C is 0. All right, so we have the shape of our parabola, we have the vertex, we have our intercepts. We're ready to graph it. Let's plot our vertex. Our x-intercepts. And our y-intercept, which is already the origin. And let's just mark in our axis of symmetry. And we're good to go. So that's the graph of this function here. All right, so next time we're going to be looking at some applications to quadratics. Why do we care about these types of functions, and what applications are there? All right, we'll see you next time. Bye-bye.